Welcome to Unreal Gems. In this video we are going to shade Citrine's gems. For that we are going to use Parallax Mapping, which is going to provide them with some depth. We are also going to use noise generation nodes in order to have some detail in the interior of the gems. Roll intro. Okay, so here we are in the engine, and this time we are going to deal with the shading of Citrine's gems. For that we are going to use Parallax Mapping, but in a different way than before. Okay, so let's dive right into it and take a look at the material. First things first, we have the base color, which is going to be the base color that we are going to use. We have the emissive that is going to be added on top of that base color. So this is the most simple parameter, and just as you can see has black for now. We will be able to modify it in the material instance. Then we have the PBR parameters, so metallic, specular and roughness. You have a lot of videos about this topic already in my Citrine shading series and my PBR series, so check out those if you want more info. They are all connected to the pins directly, so base color to the base color pin, metallic to metallic, and so on and so forth. If you want to see the effects that they have, let's go ahead and take a look at how the base color changes the final output. If you go ahead and give it more oomph, like let's change the hue, and as you can see, it is a small highlight. You can see it better in the preview panel, but as you can see in our model, it also appears, but it needs a lot more strength because the emissive is a lot more apparent. So if you want to see it, you need to dial it up a little bit. But as you can see, it's quite a small touch, but it brings a nice look to the gem. So I quite like it, but as always, I want to be subtle and I don't want to go overboard. So I'm going to cancel it and keep it as is. Let's go ahead and check out the next parameters, which we already said that they were metallic, roughness, and specular. So let's go ahead and turn down the metallic. Right now I was looking for a glass kind of look, so a perfect gem. So the metallic, I had it up to 1, and the roughness down to 0, so it is polished, perfectly polished, like a mirror. So we are looking for that perfect surface look and that perfect gem look. Again, I'm going to turn down the roughness a little bit so it is not matte, so we can see specular highlights. Remember that I chose a metallic of 1 and a roughness of 0, but right now I'm going to turn it down so we can see the effect of the specular better. So let's go ahead and leave it in a middle ground and turn up the specular. As you can see, specular highlights come up a lot more and are a lot more apparent, and if we turn it down to 0, they are all killed. So with this, you can see how you can give it the look that you want, and we are going to go back to a lower specular, and so that we have specular highlights that are not so apparent, and always check in the viewport with our character to see that it looks good. And let's go ahead and turn it up a little bit more so we can see them, because I think I had them too low. Okay, so let's go now to the material and let's take a look at the normals. As you can see, the setup is quite simple. We have a normal texture which comes from Quixel, so nothing to do with the gem, but we want to be able to give it a little texture if we want to. So that's what this small texture is for, sampled as always with the default settings that Unreal auto detects when it sees a normal map. We are using a new node here, which is called Flatten Normal, which uses the normal texture and has a flatness parameter which controls the strength of the normal map. We have inverted it because it flattens it, and we called our parameter normal strength. So that's the reason why we have a 1 minus x. Pretty simple. So if we want to see what the flattened normal node does, we are going to preview the node so that we can see the effect. So let's go ahead and right click and start previewing the node. And now if we change the normal strength, if we go to 0, so no strength, no normal map, so blue. And if we go to 1, the original normal map unchanged. 0.5 is a middle ground. So let's go ahead and stop previewing the node. And as you can see, this is it. If we change the camera now, you are going to see that in the surface, we have a small detail that looks like the gem is not perfect and it has imperfections. Let's go ahead and turn it up so you can see it better. And as you can see, it looks like in the surface, it has those small crevices and those bumps that are due to the normal map. So in our case, we are not looking for this type of look, but if you wanted an imperfect gem, maybe a gem present in nature, you can use a normal map to give it that small fine detail that an imperfect gem would really have. So in this case, let's go ahead and go to the material instance so that we can see the effect of connecting this node flattened normal to the normal pin. And let's see the effect in the previous scene with Citrine and her gems. So let's go ahead and switch to our material instance, and let's go ahead and choose the normal strength parameter and go up to 1. Let's turn down the metallic so that we can see specular highlights, which will make the normal map more apparent. And that's pretty much it. As you can see, we have now a fine detail in the surface of the gem. As you can see, we can dial in the effect to get the look that we want. And as always, I try to be subtle. I know that I repeat myself a lot, but I think it is important to not go overboard with these effects because they can look weird. And if you keep it simple, it's going to look great. So let's go ahead and go back to our original look. And now let's go back to the material also. And let's take a look at the most complex part, which is going to be the noise generation and the parallax mapping. Don't get discouraged because they have a lot of nodes. They are quite simple. So right now let's look at the emissive color, which is the only thing left. And let's start on the left with the parallax nodes. Okay, so we have a couple of nodes here to deal with the tiling of the parallax effect. So that's why we call it interior scale. You are going to see that it will vary the interior detail tiling. Then we have the bump offset node. We are not using POM, so parallax occlusion mapping, because in this case I felt that we didn't need the precision, and this node is quite more performant, so less compute intensive. Next, we have the height parameter, which is going to say where the interior surface is going to be, and the interior offset, which is going to exaggerate it or make it less apparent. So the parallax effect, I mean. Next, the bump offset node is going to feed the texture sampler, which is going to make this cool parallax effect, which makes it so that it looks like it has interior detail, kind of like ice, for example, which is possible due to the fact that the noise does not have its texture coordinates altered. So the bump offset is only going to modify the texture sampler, and then it's going to be multiplied by the static noise. That makes it so that it looks like we have two surfaces, but we only have one, and we have two types of noise that are being multiplied. And as you can see, if we preview the node, they look like they are separate, but it's just an optical effect that we achieve mixing the static texture with the dynamic texture that we get with the parallax node. As you can see, it looks like it is static, but when you mix them together, they move at different speeds. And as you can see, the texture has nothing special apart from the fact that its compression settings are set to masks, so no sRGB. There is no color information here. They are just noise textures that have been packed together in each channel, and they have no other use but to sample the noise and lets us modify their texture coordinates so that we can get this cool effect. Let's go ahead and preview the node again. As you can see, we have our grayscale map with the different surfaces. And again, thanks to the noise generation, that it is static, and our dynamic texture that is driven by the bump offset. And as you can see, if we turn on the output again, you can see that we have those two surfaces being displayed, and right now you can see that the effect looks really good. It looks like we have kind of an interior surface, and it looks amazing in my opinion. So let's go ahead and take a look at this material, this part of the material, but in our material instance, it's quite simple. Let's go ahead and modify the different parameters and see what they do. You can see that the height is going to make the surface closer to the exterior surface or further away if we go down. So the effect is going to be exaggerated if we do this. So the parallax effect can be controlled with this parameter, and also with the interior offset, which is going to exaggerate or make less apparent the height number that we chose. So in this case, you can see that the parallax effect becomes quite distorted if we go too far, and if we make the surfaces too close, it's going to have almost no parallax, and it's going to look like the surface is stuck to the other surface. So in terms of the interior scale, if we change the number, you are going to see that the tiling is going to become more apparent. Depends on what you want, but you can make the noise texture bigger or smaller, and you can dial in the look, always looking at the character in the viewport. And as you can see, well, you can go with bigger detail, but at some point you're going to see the pixels in the texture, so you need to be careful. And if you go too small with the tiling, a big number, it's going to maybe make the seams of the texture visible, so you need to be careful. As always, I'm going to leave it at the number that I chose before. And with that, this is pretty much it. You can see the effect. Turn the camera. I cannot turn it in the viewport because this is a sequence. So right now it is static, but if you want, you can go ahead and in your project fiddle with it, move the camera and take a look at the viewport, and you are going to see the effect in all its glory. Okay, so here we are again in the material. This time we are going to take a look at the noise generation. We have two simplex noise nodes. In this case, you can see that the first one has a bigger pattern, and the second one has a smaller pattern of the same kind. You can achieve this with the same parameters that I used in the node. As you can see, varying the scale and the levels, min and max, you are going to be able to get these results. You can experiment with this because there is not a correct way to do this. It's whatever you feel like looks best. Next, we will have the lerp, which is going to merge those two types of noise depending on a pattern, which is connected to the alpha pin. So the green channel in that texture that we saw before is going to be driving the lerp. And as you can see, it just merges the pattern and it mixes and matches between the two noise patterns. So it's just so that you can not see the real pattern, and it's quite a lot better this way. Next, we multiply it by the UV modified texture, so the blue channel in that texture that we saw before, and this time that is going to create the parallax effect as we mentioned earlier, because the noise is static and the noise in the texture sample is not. Bear in mind that the noise nodes can get quite expensive, so if you can avoid using them and you can use textures, that's a pretty simple optimization that you could do in this material. Next, let's just look at the color. So right now we have a grayscale pattern and we need to add those splashes of color that the gem is going to have. So first things first, we have that smoke texture that is going to drive a part of the material. So that's going to be the first splash of color that we are going to have. You can see the result right there. And again, we are going to mix it with the inferior part, which in this case has the already present texture with the parallax, and is going to multiply it by the color like above, and that's going to make it have a splash of color. Next, we have a lerp that it's going to allow us to mix those intermediate results, and that is going to allow us to have the output to the emissive. So we can mix them with the alpha parameter. We are going to be able to choose the quantity that we want of each pattern, the smoke pattern or the randomly generated one with the parallax mapping. And last but not least, we multiply it by the emissive, which is going to give it more light or less light, more emissive or less emissive. And that is going to be the last touch that we are going to perform. And next, we just have to connect it to the emissive color. With that, we can go ahead and test it out in the scene, and you are going to see that it is quite simple. We just have two colors. Those are going to be the primary and secondary colors. One is going to affect the smoke pattern, the other one is going to affect the noise. The emissive is quite simple. If you go ahead and use 0, it's going to get rid of all the light. 1 is going to be the original, and 100 is going to be a lot of light. As you can see, I kept it at 10, which I thought was quite okay and was what I was looking for. Next, we have the alpha parameter, which, as I mentioned before, is going to combine the two types of noise. The cloud noise, the smoke noise, is going to look like it's on top of everything. So you have to be careful because it can obscure things quite a bit. It gives the gem a milky touch. So as you can see, it looks like it has clouds on the interior stuck to the top part, to the top surface. You have to be careful with this because it can obscure the interior of the gem. So it can look bad, it can look too milky. So just fiddle with it and see what looks good for you. If you want the second color to appear, the color of the clouds, we need to dial it down a little bit. So right now we can see the different effect with the two colors. So let's start first with the dynamic noise, the parallax noise. If we change the color, you are going to see the interior part change colors. So we can make the gem pink or purple or whatever we want, white. You can see what looks best. And again, there is no right answer here, so you just have to test things out and see how they look. With the second color, you are going to see that you have to be subtle or it's going to look kind of weird. So again, if you go too overboard with it, you're going to see that the clouds obscure the rest of the patterns and it's not going to look great. I'm turning it up so you can see the effect, but as always, we have to be careful so it doesn't look bad. Usually you're going to want to turn the color a little bit down, and if you go too high with the color and the alpha too low, you are going to see that it obscures everything and you cannot see anything else. A funny thing is that I have not used a transparent material. As you can see, the material is opaque and I faked the transparency of the gem using parallax mapping. That is because I want the material to be performant, and translucent materials, as you know, are quite expensive. Well, so that's it for this video. As you can see, the material looks quite complex, but it really isn't. So once you understand parallax mapping and how it works, and you understand the noise generation nodes, then it's just a matter of mixing noise textures and colors. So if this video has been useful to you, go ahead, like and subscribe, and we'll see each other in the next videos. Huge shout out and thanks to all my Patreons. As you know, making these videos takes a ton of time and effort because I research in depth all of the topics that I cover. So if you want me to keep making awesome stuff, consider supporting me on Patreon.